Okay, while that's loading, just remember what the steps were. So we replaced the sine squared with the 1 minus cos squared so that the cos and the cos match up, and we don't have different trig ratios. We don't have sine and a cos or a cos and a sine. And then we just expanded and simplified until we got this quadratic. So let's find a solver and stick it in. So that's exactly what we want. We want to just solve this equation without worrying about factorizing or anything. So normally you just type these three coefficients into your calculator. So here we've got 2 minus 11 and 17, if I remember correctly. No, it's 2 minus 17 and 11. Let me change that. And it gives the two roots as 7.794 and 0.705. Let's see if that gives it in third form. Okay, no, we'll just deal with that. So 7.794, we can say that C is equal to 7.794, or C is equal to, the other solution was 0.7056. So now remember that C really stood for cos theta. So cos theta can be brought back in again. So let's type in cos theta. And bring that back in. Cos theta is equal to, for the first solution, 7.794. So on a calculator, if you type in inverse cos theta, inverse cos, and then 7.794, you'll get an answer for theta. But I don't think that's going to work. So you might get an error. So in that case, that tells you actually the first answer can be ignored, and it's the second answer you want to go for. So then when you type in 0.7056 and inverse cosine that, remember we're working in radians, so you should then get what theta is. That'll be your first solution. So let's try that now. You can try it as you're waiting. So you want to take inverse cos of that number, 0. We'll take a look at it in a second. 0.7056. There was more to it. I've just rounded it with. If you've done this if you've got those two solutions on your calculator, stick with the full number. $7,056 followed by 3828. So let's just stick that on. Accuracy is going to be quite important here. Okay, so let's grab our calculator, let's stick it into radians mode, and let's get the inverse cos of 0.7056, 3828. You can do this on your calculator as well. See if you get the same answer. So the angle here now is 0.78747. So let's type that in. Theta is equal to 0.7874 72, and there's more. I'll just put dot 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 there to show that. Okay, now that's your first angle, but don't stop there because the cosine graph, as we saw in the previous lesson, you've got the cosine graph coming down and then back up, and then it cycles like that. So when you hit the first value of theta, then it'll hit it again because it's going down and then back up again. So at the moment we had cos theta as being 0.7, so that's about here. And then the angle that we've worked out by doing inverse cos is about here. So we can carry, the graph will then carry on, but it'll hit that same value around here. So we want that other value. So don't just stop at the first value, but generally with the cos graph, very easy shortcut is think of the whole graph as spanning 360 degrees, or in this case 2 pi, and just subtract your first answer from 2 pi. So type into your calculator 2 pi, take away 0.78, 7472, and that'll give you a second answer. One answer isn't going to be enough to get you full marks on these kind of questions. So let's type in 2 times pi and then take away 0.787472. So you'll get a second answer of about 5.4957. And then you can round each answer to the appropriate rounding, and normally 3 significant figures. So this one would become 0.787, and this one would become 5.49, would go to 50. Okay, let's just check nothing's gone wrong on that. You can just go through the working again just to make sure you've understood that while I load up the answer. So if you're doing that last bit on your own calculator, you want to start with 2 pi and then subtract your answer to the first angle. Okay, let's check out how those answers compare. The method in the book might be slightly different, so we're just going to ignore that. And what we've got is theta is 0.84, and then you've got your 2 pi take away 0.84 to give you a second angle of 5.44. So the first angle doesn't seem quite right, so let's just double check. It's 3y squared minus 17y plus 10 for the equation. So let's just see what's gone wrong there. Okay, so we've got 17 cos theta, and then we're adding 2 and then subtracting 2 cos squared theta. Okay, so then still okay is equal to 13. The plus 2 can go over to the other side, so that's 11. Then you've got 17 cos theta minus 2 cos squared theta. That change the signs around. So this 11 here is still okay. So we've got, let's just do the little in between. So you've got 17c minus 2c squared. Bring the 11 across, that's minus 11 is equal to 0. 17c and the minus 2c squared, we want to change that order so the higher power is at the front. So it's minus 2c squared plus 17c minus 11. Swap the signs around now, so that should read exactly what we've got below. 2c squared minus 17c plus 11 is equal to 0. And the solution in the textbook had 3 cos squared. So let's see. Not really sure how that's appeared in the textbook. Could be that there's a mistake on this page, or it could be the questions just being done wrong. If I find the mistake, I'll redo this, but otherwise this is looking good. We can check the answer by just taking one of these answers and putting it back in, and that would work. So we just want to take 0.787472 or your 5.495, and you just want to put it back into this and see if it gives you 13. Join me again for the next lesson on more trig equations. Assalamu alaikum wa rahmatullah.